to.
Yeah, it's not like.
Oh, okay, no. Okay.
Save.
I was thinking about charging it, I was like, nah. 2% should be
I guess able to read bullets, right?
Yes.
Yeah.
I agree.
I thought you could tell if it was considered or not if the bill was there.
You know, one of the seats for right there. Good.
Okay, anyway, so I'm gonna just be going over last semester's third exam for this review here. So first I've written the section of true or false questions. So we'll just go through each one of these. So we have 5 true or false questions. Are there any questions before I get started? Okay.
What's number 4?
What?
Number 4?
Well, what about it?
The very information claimed found by the.
I can't hear what you're saying. What?
I just don't understand what it says.
That's why they came over it.
True or false, that's what
Starts
it is.
with-
Yeah, pretty much.
Review.
It's a question. Remember how every different area had to be.
Anyway, so we'll start with the first one here. So we have the line integral. So let's suppose that this is some curve C. So this is like the start of it, and this is the end. So we have this line integral. So this is C. So this would be positive C. We would be going this way. But if instead for C minus, you see on one of those sides we have C minus. C minus, we would be traveling the other way. So we start at the end and go to the start of the curve. Because this would be a curve that we suppose as you increase, it's parameterized by some function R of t. And as you increase t, you'd be going this way for C. And then for C minus, as you increase t, you'd be going this way. So the question is whether the line integral going the opposite way of the scalar field f, ds, would be equal to the line integral going in the positive direction of that. And because we have ds here, this is just a line integral for arc length. Because we have that ds, so you have the integral f ds equal to the integral at some starting time and some ending time of f of r of t times length of r prime of t dt. Because we have that r prime of t dt just equal to ds, because if you were to divide both sides by dt, you get length of r prime of t is equal to ds over dt, which is something that we had talked about in class. Well, really, actually, that was the length, but yeah. So anyway, this would be, the answer would be yes, because arc length does not change in value depending on which way you integrate it, because it's a length. So it makes sense that it wouldn't matter which direction you integrate it. Other questions about that? Is that pretty clear? Okay. So here we write that would be true. Okay, so for our next one here, we have for our conservative vector field, F, we have so does anyone know what this operation is called?
Curl.
Yeah, so this is saying the curl of F is equal to 0. And yes, that actually is true. And you recall that if you have F is just equal to some function in R2 of pi plus qj, you have that the curl of f would just be d p dy minus q dx. But if f is conservative, these two quantities are equal to each other, so you have that the difference of them would be 0, because they would cancel out. So yes, that is true, that if you have a conservative vector field f, then the curl of it would have to be 0. Yeah, questions about that? That's pretty clear. Okay. All right, so now we have, if f is equal to that, and those are equal to each other in an open connected region D, then f is conservative. Is that true or false? Does anyone have, this is a tricky one, does anyone have a guess? Yes?
I would say it's false because it's an open region.
Does anyone have any other reasons as to why it would be false? It is false, but there's a different reason. Any guesses? Okay, so it is a necessary condition, but it's not a sufficient condition for it to be conservative. For it to be conservative, you have to find some potential field little f, such that the gradient of little f is equal to big F. This would mean that it's conservative. But if this is true, but here we're just saying, we're just supposing this is true. This could be false. There might not be such little f whose gradient is equal to that f. And yeah, so this is a necessary condition, but it's not sufficient. And this question is saying, suppose we have that. Does that imply it's conservative? But it does not imply it's conservative. It's a necessary condition. That could be true, but there might not be such little f whose gradient is equal to big F. Yes?
So every time we use it, for the purposes of the exam, if we do that, we can imply that a function is
So if we do what?
like
If
we
you
use
do
that,
this,
like that other one.
this?
Yeah. Or do we have to like show it? Because that just says, I think I'm gonna, never mind.
Yeah, it's tricky. So this is a necessary condition. So if we, let's suppose that it is conservative, which is true only if you have this here,
Yeah.
you have to have this. And if you do have that, you then have f equal to the gradient of f, but that would then be, so the gradient of f would be dt over dx, dq over dy. But anyway, so yeah, that's a necessary condition, but not a sufficient condition. You need to have this for it to be conservative. Other questions? Is that yeah?
Yeah, it doesn't have to be open to be conservative, right? It doesn't have to be open or closed for it to be conservative, right?
No, yeah, it doesn't have to be open or, no. Yeah, all of that's just a layer right there. That's not important here. Yeah, that's just very off. Other questions? All right, yeah, that was sort of a tricky one, but anyway. This one is a bit interesting. The area of the region in the plane bounded by a closed curve. This is the important part. A closed curve C is equal to that. So, that's kind of aggressive there. So, let's suppose that we have this closed curve C. Let's just suppose it's oriented this way, just for sake of explanation. So, if you have this, let's call this region D. So, if you take the double integral over that region D of 1 dA, you end up getting equal, you get the area. So you get the area of the region in the plane bounded by that curve. And we know through Green's theorem that you have the line integral over a curve C of P dx plus Q dy is equal to the double integral over the region D of dq dx minus dp dy dA. So we would have to have this inside part equal to 1 if we are going to be getting the area. So yeah, we will have to have that difference equal to 1. And what we're going to do is we're going to take a look at here and compare the two of these and figure out what P and Q are. And then we'll calculate this difference here. And if we get 1, then it's true. And if we don't get 1, then it's false. So we're essentially checking to see if whatever vector field we have represented by that difference of line integrals is one that the one whose curl is equal to 1. Because if the curl of it is equal to, that's the curl. So if the curl of that vector field is equal to 1, then it is a special vector field that has that property. I know that's like probably quite confusing, but does everyone sort of see what I'm trying to say here? So we're gonna figure out what this vector field is in terms of P and Q, then we'll take the curl, and if we get 1, then it's true. Because it represents the double integral of 1 dA, so it would perfectly equal the area. So, here we have minus a half y times dx, so we have P is times by dx here, so we would have that P would have to be equal to minus 1/2 y. And here we have 1/2 x dy, so that means 1/2 x would have to be equal to q because we see q is paired up with y. So then q is equal to 1/2 x. So now we'll figure out what this difference here is. So if that is what P and Q are, we'd have dq, dx would have to be equal to 1/2 because q is 1/2 x. And dp dy would have to be equal to minus 1/2 because we have p is equal to minus 1/2 y. So then if you take dq dx minus dp dy, you get 1/2 minus 1/2, which would be 1/2 plus 1/2, so you get 1. So the answer would be yes as a result of that. So this is true. And, oh, I meant to write this. Questions about that? There are no questions? It sort of makes sense. I know it's probably very confusing, but yeah, so we have to use the Green's theorem here. So we identify what our vector field is in terms of P and Q, and we take its curl, and if we get one, then we have the double integral of 1dA would exactly give us the area. So then we just have to check if the difference of those partials, dx, dpdy, gives us 1, and we found that it did. So it's true. Questions? Okay, anyway, so that was 4. Now we have question 5, which is going through here. So if the conditions of Green's theorem are satisfied and double integral of dq dx minus dp dy dA equals 0, then this vector field is conservative. Well, if the vector field is conservative, we would have to have this difference would equal 0. So yeah, so if that difference equals 0, then we'd have a double integral of 0 dA, which would have to be 0 regardless of what the region is. So yes, the answer would have to be true. So yeah, so this was true, true, false, true, true. Yeah.
So that's an inversion of all the other ones.
Anyway,
So this last one, you say it's conservative because dp dy is equal to dq dx?
yes,
But I thought in the third one you said that's not enough.
it's a necessary condition.
Yeah.
We're told that it's conservative, so that had to be true.
Well, we're not told it's conservative. The question
Oh,
is
wait,
if it
And we
is
still have like
conservative.
at least 8 hours to study though.
But I thought in the third one you said it's not enough to say it's conservative.
Skip class, bro. You need to study, bro.
Because if that's the case, then that's
This is like the big scary in my perspective.
I see what you're saying.
What says if the conditions are satisfied? So like, you're assuming that everything else is already.
Because you have to.
Because it says if the conditions
Yeah.
of Green's theorem are satisfied, meaning if all of that is true plus
I feel the
that
same
equals
way.
0, then
Thing is, you can
What'd you get?
use Green's theorem even if the other conditions are set. Shoot, yeah, my next.
Oh, shoot. Well, you can use it.
What if the answer key
I got a,
Do you have an answer key for
Right
this?
now.
I got a.
I do not.
Gotcha.
He's just going off of it.
Close to an A.
How would it not be true?
But I need to do.
The thing is, yeah, because this is only a necessary condition for this to be equal. You can suppose you have some vector field such that that is true and you would get 0. And the Green's theorem being satisfied just means that the curve you're integrating over is closed.
Idea behind it.
But that doesn't
I
imply
know,
that
I've
it's
kind of explained it,
conservative.
but I don't understand.
I just googled it, it says Green's theorem only works if it's conservative.
It's only equal to 0 if it's conservative. This double integral is only equal to 0 if it's conservative. You can still apply the double integral to get something that's not equal to 0.
Because that's just like, oh, that makes so much sense.
Sorry?
Isn't it already conservative because of the first statement that Green's theorem is satisfied?
Green's theorem satisfied just means that you have a simply connected closed curve you're integrating over. But just because that curve is simply connected and closed does not mean that the vector field that it's in is conservative. Yeah, so I'm actually gonna have to say this is false then, which is kind of dumb. But-
Yeah, I hope we don't get questions like
Yeah, I
that
hope we don't
tomorrow.
get that one. That one's
Why do
gonna
we
be-
say it's false?
Because this difference could be equal to 0, and it still might not be conservative, because that's only a necessary condition. It's not a sufficient condition for a conservative vector field.
Pretty much for the same reason why
Yeah,
number
so-
3 is false.
Jacob's corner said it would be conservative if that is equal to 0. Yeah, like it is conservative, not can be.
It's a necessary condition. I don't think it's sufficient.
Well, so.
Because you could have a vector field such that that difference is equal to 0, but you might not be able to find a little f such that the gradient of that is equal to big F.
So is the only condition for Green's theorem is that it's closed and connected?
Simply closed and connected, yes.
So it doesn't matter like what the curl is or?
No, it doesn't matter what, if it happens to be conservative, you'll take the double integral and you'll get 0, because if it's conservative, it inherits the property of the difference being 0. So you get 0. But that's not a sufficient condition, that's a necessary condition.
So it's a case of
Anyway, yeah, so I would say
all squares are
true,
rectangles, but not all
false, true,
rectangles are
false.
squares.
Yeah.
Because like, why would they
tested.
Other questions about this?
Well, based off this
Okay,
being last year.
usually the true or false is like the
That being
strictest
said, I
section
will prepare
of all of them, so the rest should be simpler than this.
I'm screwed.
Is it okay if I erase this? Is that okay?
I don't know, I'm sitting there, I'm typing as long as I can.
Alright, we'll have to figure out which of the following expressions are meaningful. So we have little f, which is a scalar field. Well, yes.
Can there only be one right answer?
Well, what?
Is
Some
big
might
F
be
a
meaningful, some
vector or
might
a
not be
scalar?
meaningful.
Big F, I'm pretty sure.
Like,
Big
can there
F
be two
is
meaningful
the gradient of
options?
little f. So,
So it's a vector.
yeah.
Well, then the first one would be meaningful.
Anyway, so we have little f, scalar field, big F, vector field. So,
Oh,
this is sort of a review of operation here. So we have the curl, which is represented by the gradient, or sorry, the lambda crossed with f. So here f is a vector, and the cross product of those will give you a vector. So for curl, we have a vector,
What's the difference?
and it goes to a
Oh, one
vector
big, one small.
after you apply the curl.
So it's a scalar
okay,
field.
so.
That's not-
So we start with a vector, you apply the curl to it, so you get another vector.
Scalar and a vector.
The divergence that is represented by
Gradient of a
lambda
scalar
dotted
is a
with f,
vector.
which where again f is a vector. So we have a vector going in,
Vector dotted with a vector cross.
namely f,
Yeah, no, that's that. The last one,
and the dot product, you get a
the
scalar.
last one makes sense.
So through the, applying the divergence of that vector, you get a scalar. And so that's the curl, that's the divergence. Lastly, we have the gradient.
I didn't actually do them all.
Which is represented by that. And here, this little f, which is little f is a scalar. But when we take the gradient, we get a vector. So we have a scalar going in, and then you apply the gradient, you get a vector. So in summary, for curl, you have a vector going to a vector. For divergence, you have a vector going to a scalar. And for gradient, you have a scalar going to a vector. So we use all three of those to figure out whether each of these have meaning. So for the first one here, we have a vector. This is the curl.
So.
That is the curl. So that's going to be a vector, that's going to go to another vector. So then we have the divergence, but for divergence, you start with a vector. So that's meaningful. So write meaningful. Here we have, this is the divergence, so we have, the divergence. And that is going to give you a scalar, but the thing is, we then have the curl, but we can't take the curl of a scalar. So this is not meaningful.
Let's go.
Okay, for this next one here, we have, this is little f, so that's the gradient, which is going to go from a scalar to a vector. So then we have the curl of a vector, which is meaningful.
You don't know vectors and scalars work.
Here we have the curl, but it's of a scalar, so it's not meaningful.
Yeah, I think a lot of 3 points.
Here we have the gradient of a scalar, which is a vector. Then we have the curl of the vector, which goes from a vector to a vector. And then we have the divergence of what is then a vector, so that's meaningful.
Let's go.
Anyway, so meaningful, not meaningful, meaningful, not meaningful, meaningful. Questions?
You still have like 16 hours to study. We're good.
This made sense, this explanation here. Oh, hopefully this helped. So yeah, so we have scalar field, we have vector field, we have a curl, goes from a vector to vector. Divergence, vector to scalar, and then gradient, scalar, vector. Is it okay if I erase this?
Yeah.
No.
me and him do have glasses. We have similar haircuts. You see that before?
He had like a hair color that's opposite.
Yeah, his is like mine's a dirty.
Yeah.
You have a closer hair color to him.
Yeah, that's right.
Oh no, here. We're right now.
Well, it's even darker than your hair.
I'm just gonna finish this.
You are now Jacob.
Yeah, this is all the
How strong are your glasses? Can I try?
Sure.
super strong.
I know. This is why they already like that.
Really definitely stronger.
The one side. Oh, we just sharing glasses.
This is.
Okay.
I don't know. I think those are stronger. Because they're more blurry to me.
Those make my eyes feel like they're forced to focus on them directly in front of me. Like they're like
Really? This side
focus
is
towards the middle.
This side is farther.
Let me finish writing this.
Y equals. Yeah.
Oh, I don't know the type
One minus Y.
Oh no.
Oh my.
I'm screwed.
Okay, so, the question is, which of the 5 of these, and well,
I think.
the other option is not as well, I'm not gonna write that down. but-
I think
So the
type.
question is,
I think
so we have
type
this
3 is
figure
using
here,
Z.
and it was actually on,
Actually,
so
easy.
this is the figure, the question is, which of the 5 of those, if any of them, is a type 3 representation
I think
of
type
this
1
region
was
here?
on the x-axis.
So,
type 2 was on the
the
y.
type
So
3 representation,
means you do Z last, I think, right?
so type 3, we have to integrate y first.
Oh god.
So that, so dy is gonna be the first integral, and then we'll have 2 other integrals outside, but the point is for type 3, you have y as the first one.
So can you tell us what type 2 and type 1 are as well?
Type 1 is X, type 2 is
Alright, so this is type
So
3.
type Z.
So-
type 1
I'm pretty
is
sure type 1
is Z.
So
Type 1 is Z.
that means
He
it
said type
can't
3 is
be,
Y.
can't be that or that or that.
Type
To
3 is
end.
Y.
Okay.
Because, look, none of these start with y first. So you already know it's none of those.
So if it. If
So it could be
if
either
which
this one or
you
this
aim
one,
at,
or,
right?
well, theoretically,
Which one you decide.
neither of them.
Nah, but they would probably start with that.
But, so let's just check to see if this makes any sense here. Well, for the second integral, you have x in one of the bounds, but you're integrating x, and you can't do that. So it's not this one either. So it's either this or not.
Third one?
Well, I mean, I guess that's always, that's like a vacuous statement, that's always true, but, yeah, so down here, there's the invisible some other answer option, which I've chosen to omit. But we're gonna check to see if this is right. So, well, so let's go ahead and look at this first one here. So, y, this is two functions of x and z, so we'll be looking at R3 here. So we have the lower function for y is the xz plane. Or, yeah, sorry, it's the y equals 0 plane. So, this is x, y, and z. So y equals 0 is the plane over here on this wall over here, and you see that is in fact the lower bound. Is that everyone's okay with that?
Yeah, sorry.
So the upper bound is the plane 4 minus z. So this is y is equal to 4 minus z. So y equals 4 minus z. If you were to solve for z, you have z equals 4 minus y, which is in fact right here. So yes, we are covered by that plane, which is good. That's right. Does everyone see that? So we're bounded by y equals 0, and then we're bounded by the plane z equals 4 minus y, which is just a rewriting of y equals 4 minus z. So this integral that's checked, that's good. Let me check the second one. So we have z bounded by x equals 0. So x equals 0, that would be down.
The y.
So that's
the
actually a good
y-axis.
choice. Yeah, so x equals 0 to 4 minus the square root of x.
Okay.
So
Yeah, that makes sense.
Here you see y is equal to square root of x, so then z is equal to 4 minus the square root of x.
Yeah.
What is the?
So we have z goes from 0 to 4 minus the square root of x, that's correct. Because we just showed it right there. So that's right, and then x, does x go from 0 to 16? So that's a good question. So
Yeah.
yeah, we have to figure.
Z equals 0, y equals 4.
Yeah, so that I believe should be true,
So,
because
yeah,
if
for
x
equals
is equal to
x.
16, you have z equals 4 minus 4, which is 0.
Yeah.
So z never goes negative.
Yeah.
So, yeah, I believe that's correct. So then, yeah, this would be the correct answer.
How is, I thought isn't type 3 when z is the one moving between 2 points? The last one.
Sorry?
Is it,
For type 3, we have first integral has to be with respect to y.
So what's the reasoning behind that convention?
It's random. Or it's arbitrary.
Okay.
Oh, I thought it
Anyway.
was
Okay, so what is type 1 and type 2 then?
So type 1, we have z is the first variable being integrated. And then
That's so
for
gross.
Z, X, Y.
type 2, you have x.
Is the first one.
Who
Yeah.
invented this?
That's a good question.
I really thought it was.
Anyway,
That was
other questions?
Yeah, it makes sense that way, but.
Type 1.
Man, I just don't like common sense.
Can you just explain the X bound game real quick?
And then they just added,
I'm glad we saw
You're
that.
bound
just
for
for like,
like
Okay,
going
yeah,
extra.
then they just added
Alright,
something from.
so
X, Y.
so this is equals 4 minus x.
That they built
If
two
z is
Z's.
equal to 0,
Type
so
one
we're
pushed
on the
X
xy
and Y.
plane, you have
Type
0.
three would then be Z.
Z equals 4 minus the square root of x.
The only thing I can think
So
of.
that
is
means
starting
x has
in
to
the
be
middle. Type
16
two is
at
the
its maximum.
real type 1, and then it's X.
And at its minimum, well, you can see this is in the first octave, so the minimum, of course,
Oh,
is
that's
is that one.
You would then go X, Y.
It's like rotating.
Okay.
Yeah.
That thinking that on the spot, anyway. So I did it, so. Anyway, are there other questions before I erase this? Alright.
That's a good code.
You know, 2 months, no, you can do that, you're right. Yeah. Or you'd have to do 4, and then there's no point. What?
There's always like nothing else.
Oh, okay.
Well, you didn't know that,
So,
gotta make the most of it.
substitution thing. It's 4 questions, 5 questions, but then after that.
The whole thing. Yeah, it should be a page. I don't know.
How do you use a Jacobi integration?
It makes the bound similar. Presumably, the nice thing is that they're telling you already, the bound, so all you're trying to do is find that fraction on the outside, well, that's part of it, find the fraction on the outside, which involves you taking the test. So when you take the Jacobi, you always take the absolute value, so you can knock off the -1 out of 14. So that just improved your chances by a huge bit, without actually doing math.
Unless there's a negative somewhere in there, they just pull it out.
No, there wouldn't be, because the function that you're integrating here doesn't have negatives.
No, that's not.
And then you multiply by a Jacobian.
Anyway,
The Jacobian.
I've written enough to articulate how to do
I
this.
highly doubt it's 2 steps.
So, we have this double integral here, we're told to make the substitution, u equals that, v equals that. And R is a polygon with those vertices. It said, the question said trapezoidal region, but I didn't feel like writing that, so I wrote polygon, which is also true. So, we have these 5 nice options here. The question is, once we make that change of variables, which of the following would be the resulting new integral in the UV plane as we go from the XY plane to the UV plane? Post substitution, which of these would be right? So to figure that out, we will have to find the Jacobian of our transformation and include it in our post change of variables double integral. And we'll also have to find the bounds of our new region in the UV plane.
Bounds are the same on all of those.
Actually, yeah, we won't have to find the bounds. So we can skip that. Oh, well, actually, well, there's an invisible some other answer here, so theoretically we have to find the bounds. Yeah, so-
No,
Yeah, no, we will have to, because
Don't do that
that
to
could
us.
theoretically be what's wrong. So, I don't think it will be, but it could be. So we'll have to, so, if u equals y minus x, this guy up here, that'll become 9u over v.
Oh, that's a, okay.
So,
That's just a constant.
that immediately allows us to eliminate this one, that one, the two of those. So it could be either 1, 3, or 5. Because those ones all have 9u over v. And yeah, now we have to check what the Jacobian is. So,
So whether, last first one was the last one.
anyway, yeah, so the Jacobian. So that'll be the determinant dx du, dx dv, dy du, dy dv. So, theoretically, we would have to solve for x and y here, but we're going to take a shortcut, because this is actually equal to 1 over, it's a pretty big 1, that is equal to 1 over the determinant where each of these guys is just flipped. That's the only difference. So we have du dx, dv, dx, du dy, dv, dy.
That's in the holy water.
So we get this. And we already have u and v as functions of x and y, so we can just write in the answer. So partial of u with respect to x, you have minus x there, so you have minus 1. Partial of u with respect to x, you get 1. Partial of u with respect to y, you get 1. Partial of v with respect to y, you also get 1. So this is 1 over negative 1 minus 1. So that's going to be minus 1/2. Although the thing is, in the formula for the Jacobian, if you start with some function of x, y, the a, that equals, in our u region, uv, you have to take the, yeah, exactly, you have to take the magnitude of the Jacobian. So we'll end up having a 1/2 in here as opposed to a minus 1/2. So then we have f of x of u of v, y of u of v. I'm not gonna write that, but you see what it would be.
That's
Anyway,
first
so, yeah, we'll have to have a 1/2 in here.
That's tricky. Yeah.
And,
First one's right.
yeah, so then I think it would just be none of these.
The first one's right.
I think it's just the first.
It's 7 halves, and there's a 7 on the outside.
Oh, shoot, you're right. Yeah, you're right. Yeah, I totally forgot about that.
Do
We
we
have a
need to check the
second
bounds
here?
though?
No, they're all the same.
It would be this guy, because we'd have the 7 times this,
Oh wait,
the
there's some
magnitude of
other-
that, which would be 1/2. So 7 times the absolute value of minus 1/2, you get 7/2. This is the right one.
Could there be some other answer? Do we have to find the bounds because some other answer could have different bounds?
Shoot, you're right. Yeah, we kind of do have to do that. Yeah. I'm pretty sure it's just going to be A, but let's check.
Can you explain the reciprocal thing?
Yeah, so
It's pretty helpful though, that makes it a lot easier.
traditionally, when you go from the xy plane to the uv plane, for a Jacobian, you have, the partials all have x and y at the top. But if you take 1 over the determinant and then take the reciprocal of each one of these, so dx du becomes du dx, dx dv becomes dv dx. You just take the reciprocal of each partial, and then that's
So that way you don't have to do
It's
this
because
whole
you're
figuring out.
swapping which you're
Yes.
doing with respect to, that's why. Okay.
Well, let's suppose that we didn't have that and do it the traditional way. So you have u is equal to y minus x, v equals y plus x. If you take the sum of the two of these equations, the x will cancel. So you have u plus v
So it has to be in the
equals to 2y, and y is equal to u plus v over 2.
U at the top and X on the bottom.
X is
And
V minus V.
if you take the difference, you get u minus v is equal to,
And then
minus 2x. So you get x would be equal to v minus u over 2. So then dx du would be minus 1/2. Dx dv would be 1/2. dy du would be 1/2 and then 1/2. So you get minus 1/4
Which is it?
minus
minus
1/4.
Minus 1/4, which would be negative 1/2.
Yeah, minus 1/2,
Which is what we got last time.
which is what I wrote here.
Yeah.
Okay, that would have been really awkward if that wasn't true. You probably would have all thought that I was like a liar. Anyway, I'm glad that was true. That saves, I saved my integrity. Anyway,
That's nice.
yeah, so now you see, at least for this example, you get a feel that that actually does work. And I'm not just telling you nonsense. Anyway,
No, this is good. This is good.
the 7 was an original. Are there any questions about this one?
Any gaps?
You have to, it's important that you have to take this out to guidance.
Very valuable for the test.
It's an important detail.
No, it's just an old.
Anyway, other questions? And this was really fast, but did it make some sense? Okay, yeah, so, is it okay if I erase this? Oh, shoot, yeah, I didn't do that.
You just plug in your,
Yeah, I mean, you just
you get
plug in the points into your,
you get positive negative 10 times positive negative 9.
Right, the length there.
anyway, if you were to plug it in, I'm pretty sure you'd get those,
Yeah.
so.
Normally we get like that's in a form that's very easy to find balance. Usually it's in the other form where you have to find the balance.
Anyway,
I've already doing that recently.
so you have a scalar line integral here, and our curve C is a straight line. You go from 0, 0, 0, 1, 1, 1. So this is R of t, so what we have to do is we have to parameterize it with some vector R of t. So we'll use the formula for line segment. So that'll be, well, I'm gonna try to derive it on the spot. That'll be 1 minus t times r naught, which is 0, 0, 0, plus t times r1. So you see, if you plug in r, if you plug in t equals 0, you get 1 minus 0 times r0 plus nothing times r1. You get r0. If you plug in t equals 1, you get 1 minus 1, which is 0, times r0, so it gets killed. Then plus 1 times r1. So you get r1. So that's it. So we'll just plug this in. So 1 minus t, 0, 0, 0, plus t times 1, 1, 1. So if we move everything in, let's see what we get. So we get, well, that guy's all gone.
0 plus
Wait,
c,
no,
0
that's,
plus d,
yeah,
0
it's all
plus
gone,
c.
it's all gone. So we just get t, t, t.
I like that.
How contrived. So we get t, t, t. And yeah, this is equal to x of t, y of t, z of t.
dr dt equals 1.
Yeah.
Anyway, so that's that. So now we will have to go ahead and figure out what this is. So we have, then t will go from 0 to 1 as traditional for a line segment. Then we have x of f of x of t, y of t, z of t. And then ds is now length of r prime of t dt.
Yeah, that's okay.
So we'll have to figure out what the length of r prime is. I can tell you it will be the square root of 3. So you'll find this guy will be root 3. So yeah, so then we'll just go ahead and plug everything. Oh, I meant the right one there.
Oh, that's for scalar field.
Alright, so this is F. If we plug in everything, you'll get T e to the T squared.
Yeah, the scalar field is a function
Root 3 dt.
r at every point. The scalar field
Does everyone see how you just do a U substitution here? So r prime of t times dt, that's just going to be dx. Yeah. Yeah, so we'll just do a U substitution here.
Maybe like gravity versus time.
But anyway, so you'll find that this will be equal to
Well, gravity has
root 3 over 2 e to the t squared.
depending on condition. The scalar field also changes.
If I went 0, 1. If you took the derivative of this, you get e to the t squared times 2t
E to the 0.
times root 3 over 2. So the 2t, the 2 and the 2t would cancel with the 2 down there. And you would just get t e to the t squared times root 3. Is everyone okay with that? So I don't have to write out this. So now we just plug stuff in. So this will be root 3 over 2 e minus 1. And that's it. So that's the answer.
That's from my baseball
Questions?
coaches at Kennedy.
Yes.
That's too afraid to take the ball. Good idea.
How do you get from ds to dt again? Like,
Yeah, so once you parameterize the curve with a vector function here, r of t, you can replace ds with the length of r prime of t times dt. And I'm just using the formula. So then where I saw ds, I've now rewritten r length of r prime times t. Yes, sir.
If it was 115, could we just treat V as 5K?
If it were 1 to...
If it went from 000 to 115, could we just treat
Yeah.
V as 5K?
Yes.
If it was 114, could we treat it as V squared?
What?
If it went from 000 to 114, could we treat Z as T squared?
No. It'd
No,
still be 1 1 1 if you did
I don't
that.
understand what you mean.
It'd still be 1 1 1.
It would be 4T.
That'd be 4T.
Well, yeah. Are there other options? Never mind. Stupid question.
Other questions?
You did go in a line.
Anyway, is it okay if I erase this, go into lecture again?
Yes. If you want to,
Although
right now you could say.
if the vector field is
Curve R of t. Alright. Anyway, yeah, so we'll have to do that. So we'll just expand this. So we have f dot dr
This is integrating over vector.
be equal to the interval where t goes from 0 to 1
F of R of D and R prime.
of f of r of t times r prime of t times dt, and that's because that's dr over dt times dt
Would it be the dot product?
is equal to dr. Yes, it would.
Okay.
Yeah, so you have to dot the two of those. We still have the dot.
Perfect.
So, yeah, we'll apply this formula here. So, we'll have t goes from 0 to 1,
Because you can.
and f of r of t will be, so this is x of t, this is y of t. So x of t is t. So this will be t times t cubed, then minus t squared, dotted with r prime of t. So take the derivative of that, you get 1, 3t squared dt. So now we have to do dot product.
It's not that many things.
So we'll have t times t, that's t to the 4th times 1, so we get t to the 4th. And then minus 3t to the 4th. So we'll just get minus the integral from 0 to 1, 2 t to the 4th. T. Let's actually, this is a multiple choice, let me see if that was actually one of the answers.
What we get, minus good.
Oh, it was, perfect.
Stops at the.
So,
Okay.
yeah. It's
Yeah,
happened,
whiteboard's a
that
good
helps.
strategy.
That's so nice.
Whiteboard's a good strategy.
That's so nice.
I'm ready. Who's that?
Oh.
Anyway,
That's so very
that's
conservative.
just all I would say that, you know, just,
Bad thing is, it's like, I don't
Mimi,
take notes
no, anyway,
anymore.
so I'm gonna go ahead and erase this. Throws here.
What is
So, to use that, RFT has to be continuous. It is, you can look at it, it's continuous, it's a circle. So by inspection, it's continuous. Now, the thing is, we need the vector field F to be conservative. So yeah, we have to figure that out to use that. Actually, no, yeah, we do need that. So we would need to find some F such that the gradient of it is equal to F, where F is given by, okay, so that would be P, and this would be Q.
That's dx.
So F is xy e to the xy. Q is x squared e to the xy. So to figure, so because we don't actually want to find this little f because that might be a bit too much work, we'll first check the necessary condition, which is that dq over dx has to equal p dp over dy. This does not imply it's conservative, but if it is conservative, which needs to be, this has to be true. So we're going to check to see if this is true, and if it's not true, then we can't use it. So dq dx, so this is q, this is p. dq dx, that'll be 2x e to the xy plus x squared y e to the xy. Okay, so that'll be that, and now we'll check p dy. So that's p, so the p dy will be x e to the xy plus x squared y e to the xy. And now we check to see if it's the same thing, and it's not, so the answer is no. Questions?
I'm sorry.
Yeah.
If these values weren't different,
If the
then
values weren't different, we would then have to find whatever, we'd have to go forth and find little f whose gradient is equal to big F. And if we can't find such little f, then the answer would be no. But if we could, then the answer would be yes. Yeah. But we first check the necessary condition to avoid having to do all that work.
And if it's not equal to 0, then.
But since it didn't satisfy the necessary condition, the answer was no.
Okay, so we do have to change that.
It's okay.
I'm a misguided soul.
Questions about this?
This makes more sense.
So yeah, I hope that makes sense. So deal with special function f, whose gradient is equal to this here. So to do that, we first will suppose that if it were to actually, if there were to exist such a little f, that would be, well, by definition of the gradient, that would have to be f sub x and f sub y, which would then be equal to f, which is going to be, which will represent as p of xy, q of xy. So here, this is that p and that q. So what we will do is we will take the partial of p with respect to, yeah, with respect to, wait, no, actually it's already seen with respect to x. What we'll have to do is we'll have to integrate p here with respect to x to get f of xy, because that'll undo this partial. Then I'll take the derivative of that with respect to y, so it's equal to q. So, that is p. We have the integral of p with respect to x would be x squared e to the xy, or e to the minus y, plus our sort of ghost function g of y. Because if you went the other way, took the partial with respect to x, g of y disappears. So now this is going to be, that's equal to f of xy, because we integrated with respect to x to undo this partial here. So now what we'll do is we'll take the partial with respect to y, and if this relationship holds, it has to be equal to f sub y. or q, because q would then be f sub y. So if we go ahead and take the partial of that with respect to y, you have d over dy of that stuff right there. That'll be minus x squared e to the minus xy, or e to the minus y, plus e prime of y, like that, which then has to equal q, which is 2y minus x squared e to the minus y. So this implies that g prime of y has to equal 2y, because you see the other two terms match. So then we have g prime of y equals 2y. So then g of y is just equal to y squared.
Plus c.
And then we just have a, like a plus c. So then that means that f of xy is going to be equal to this guy, but we fill in the details for g. X squared e to the minus y plus g, which is y squared plus c. That's the answer.
Alright, so
6-4.
Question? Yes?
Would we lose points if we neglect the c?
No, because it's a multiple choice, and that would.
Gotcha.
This would be the answer.
Some other answer.
Well, actually, let's see. Let's see. Is
I
it
think
that?
so.
But Owen, that would
Put
be
some other answers.
revealing the quiz.
And
Wait,
argue
let's see,
with
let's see,
Skinner
let's see.
enough to get it right.
On this one, it'll be A.
Let's go.
So you,
Yeah, anyway.
I doubt Miss Skinner would
Questions?
like you, but.
Alright, anyway, so that was that.
I got a positive grade for getting out of this exam.
I think just said fundamental theorem of line results.
That's just, if it's conservative field, you can just do f of r of final minus f of
No, I
r.
get that, I just don't really understand it.
Shit.
One day.
I needed like an intuitive grasp of it, so I don't forget it immediately.
One day, when you do you want to get to it? Oh, what was this talking about? Fundamental theorem of line integrals. Evaluate. Okay, so.
Attendance isn't very good at any of my classes except for philosophy, so I use that very much.
I have a lot of discussion.
Oh, I do have to do a discussion. Although CS can drop off the discussion, so I just went until I had 3 chapters and stuff going. I thought it was 2.
Physics for majors.
Yeah, senior physics major.
That's pretty much.
Academic computer science?
Mechanical engineer.
It was
Physics minor.
You're probably farther ahead of physics.
I'm thinking physics 122. That's not.
Yep, you're farther ahead than me.
How is
Alright, so we have this fundamental theorem of line integrals here.
Take the
And
lab.
Isn't that hard?
Yeah, I'm thinking. I mean, last minute 4.
I don't think this is the
Is it easier than this class?
same.
That's pretty much.
Is this the same
I'd
one?
say so. That is the same interval.
Yeah, it's the same.
Is the lab also?
Alright, so
The lab.
So we have
the lab report.
little f
The actual lab report.
equal to
I like fun labs.
x squared e to the, I'm showing what I wrote before. It's y squared. So using the fundamental theorem of line integrals, we have the line integral of f.dr be equal to f at the end, which is 2, 1, minus f at the start, which is 1, 0. So 2, 1, this will be 4 over e
To get the,
plus 1 minus
to get small f. Just minus what it was. Okay, that makes sense.
minus 1. So you get 4 over e.
So the whole integral is beginning, the end minus beginning.
And this is option C. I don't know if that matters.
Nice. Well, it's the minus beginning of the
That's not
of the scale.
Can you define the fundamental theory of line integrals in words?
If you have some f that can be represented as the gradient of a little function f, the integral of f dot dr is equal to f evaluated at the end minus f evaluated at the start, where f is the potential field whose gradient is vector.
So because it says use the fundamental,
Questions? Yes.
because it says use the fundamental theorem, we don't have to do all the, make sure it's conservative field or anything.
We just did in the last question.
I know, but if it's
Oh, it's-
unrelated,
it's-
since it says
it's the same
use
one
the
as the last
fundamental.
question.
But yeah, you would need to do that. Yeah.
Okay.
Well, yeah, because you don't know what shape the curve is. You just know where it starts and ends. So if it's not conservative, that path will matter. But because it's conservative, the path doesn't matter. So that's why it just says starting here, ending over there. Other questions?
So if on the exam, we'd have
Alright.
to go through and make this conservative.
Question is, can we use Green's theorem? So to use Green's theorem,
It needs to be a closed, so we can continue this meeting.
so to use it, we have to have this curve C that's bounding D has to be closed, simply connected, simply meaning that it doesn't intersect itself. And, yeah, connected, so,
We can check if it's connected.
yeah, so we'll have to check that.
Yes.
Because that's.
So, that guy is a, disk of radius 1.
So that is closed.
So it's closed, and it's also simply connected. Anyway, because it doesn't intersect itself. Yeah, so that's correct, and I'm pretty sure that the answer is just yes because of that. So let me, this is a multiple choice.
There you
All
just
the
yes,
options.
no, and some other.
Yes, no, maybe. Would you like to see? There's like 5 options here. Would you like to see?
There's 5 options.
Oh, yeah.
Wait, oh, it's probably,
Anyway.
you can explain your reasoning, that's probably.
Answers. Yes, Green's theorem is valid to convert the double integral to a line integral. No, because we cannot use it because we don't know enough about the C. No, we cannot use it because D is not an enclosed region. No, we cannot use it since F is not conservative. No, we cannot use Green's theorem since integrand is not appropriately related to the vector field.
So 4 no's.
Those are all the questions. And, oh, actually, we do need to check whether the integrand is appropriately related to the vector field, because to use it, this guy here has to be equal to, it has to be equal to some scalar multiple of the qdx minus dp dy. So we have to check if it's a scalar multiple of that. Because
So there was
we
another
can
condition,
factor the
right,
lambda
okay.
outside of the integral. It is and apply it to the integral. But yeah, so we have to check if, we have to check that where this is p and this is q. So we'll have to check this. So d q dx, that's q. So d q dx will just be sine of y, and dp dy will be equal to sine of x. So that means the q dx minus dp dy will be equal to sine of y minus sine of x,
Lambda equals 1.
which we are questioning if this is equal to some lambda multiple of sine of y minus sine of x.
Yes.
And the answer is yes, and you take lambda equals 1.
Let's go.
So it's true. No, so yes, you can use Green's theorem.
Wait, lambda has to equal 1 or not?
In
Lambda
this
has-
scenario, lambda equals 1. So we calculate this difference based on the vector field we were given. We got sine of y minus sine of x. We're seeing if that's a lambda multiple of what's in here,
Oh, I
which
see,
happens to
okay.
be the same thing. So in this case, we have lambda as 1. But we were just checking to see if there existed such a lambda. Yeah. Other questions? All right.
Isn't that just?
Is it okay if I just go to the next one? Dy
Actually,
equals
we have discussion.
W over d of dq dx minus dp dy.
This week and next week.
So if for some reason this was equal 1, so we had like lambda here, we could just move the lambda inside or outside. Yeah, anyway. So, yeah, we can do that. So now we'll go to the 10th question. We're touching on the necessary sufficient. Anyway, so we have this vector field here. We have to find the divergence of it as well as the curl. So the divergence, that'll be lambda dotted with f. So that's ddx, ddy, dz. Dotted with f, which is p to r. So we get d p dx, d plus dq dy plus dr dz. So we'll just figure out what each of these are. So dp dx, it looks like that'll be the same thing as what p already was, which is e to the x sine y.
Gotcha.
q dy, well, you'll see it's all the same thing anyway. So because we have the exponential of each variable that we're taking the derivative of, so it just remains the same. We get this. Questions about that?
Doesn't make sense, but I know it.
What's confusing? So in this contrived question, we had the partial of this with respect to x is the same thing as we have e to the x. Partial of this with respect to y, same thing because there's e to the y. Partial of this with respect to z, same thing as we have e to the z. And here there was no x, there was no y there, and there was no z. Those were all the constants for each of the partials. Right, so now we'll find the curl. This time it will be lambda cross with f. So instead we'll evaluate that. So dr dy will be 0. dz dq will be, wait, so this is pq, this is r. So dz dq will be e to the y cosine z. So that'll be I, and then minus sure I actually did that correct. Okay, yeah, so then we'll take dr dx, which will be e to the z cosine x. dp dz will be 0. And then we have dq dx is 0, and dp dy is e to the x cosine y. So if you simplify this, you get minus e to the y cosine z, e to the z cosine x, and then minus e to the x cosine y.
Numbers goes the homework. Problem number 7 has something very.
Did anyone else get the same thing?
fine with the
Yeah.
curl and the.
Okay.
What? Wait, no.
Well, that
Should be mine. Should be minus. Oh, wait, wait. You have the minus
You got the
J
minus with the
stencil.
minus J.
Minus on the outside.
Oh, here?
Yeah,
Oh,
the
yeah,
minus
yeah.
J stencil.
I'm sorry, it looks like a 7. This is a 7.
Cool.
So,
And then you have to. It says it.
yeah, anyway,
So you just have
Doesn't
to-
equal
that's the
zero.
curl, that's
Just
the
take the
divergence. Is f conservative?
I don't know if I think.
So, if f, let's suppose it is. If it were to be conservative, the curl of it would have to be 0. The curl's not 0.
You can ask.
So it does not satisfy the necessary condition of the curl being 0, which means it can't be conservative.
If 15 isn't that bad, then
Yes.
how bad is 20?
So we can only use that equation to prove if a vector is not conservative,
What class?
not if it is.
That's correct, yeah.
Okay.
Yeah, it's a bit of a subtlety.
Yeah.
So.
Are there any other questions?
I'm sorry, why is it not disturbed? I like to slow down.
Oh, yeah.
I'm not
So,
sure it's supposed to be pretty hard.
The curl would
Let's
have to
suppose
be
that
equal to
we're
0.
No.
if that's the case, the curl has to be 0. But the curl's not 0.
Yeah, okay.
So, the
Really?
conclusion would be
Is that
false.
easy?
So we can't claim it's conservative. Yeah.
That's about as long as I spend on physics every week.
But we sort of show it's not conservative by contradiction. We suppose it's conservative and show that there is a contradiction. So that implies that it's not conservative. Yeah.
So if it did.
Other questions? Alright, so go on to the next one.
I don't know how people, some
We're
people.
gonna figure out what it equals.
I derive them sometimes.
So,
I
to do that, we're gonna look at how suspicious all of the bounds are.
Because I have extra
You're
time.
gonna speak to us to do something.
Polar coordinate.
It could be spherical.
I think it could be spherical coordinates as well. Yeah, so we
It's
have.
just a sphere as well.
Right.
Or would it be?
Is it
No,
just
no,
square root around 16 minus?
No, let's do cylindrical.
equals
That'll
R,
be
it
easier.
equals
I thought it was cylinder.
Because we don't have to change the.
Nobody wants to use phi.
No, yeah, cylindrical would be way easier for this problem.
Because it's x squared plus y
Okay,
squared.
wait, let's draw what our region is.
Oh wait, no, Z equals that, no.
Because we're just integrating over
X
cylindrical.
squared plus y squared equals 16.
So we know it's either
See
gonna be
that?
cylindrical or spherical. Let's think about which one it would be. So
It
we'll
looks
go
like
ahead
it's
and
a
just draw our
half
region.
a circle as well.
Polar regions.
So we have x goes from 4 to minus 4. Go ahead.
Like this
Note
weird
that.
half circle cylinder.
Z equals that.
And y goes from 0 to. Does everyone see that this is going to be a semicircle of radius 4?
Yes.
It's like pointing in the positive x direction. Yeah. So that's a semicircle of radius 4. And
Yeah, positive y.
this will be like
No.
No,
this will be like that.
No.
no.
X goes from -4 to 4. Y is positive.
Oh shoot!
side of
That's
that.
wait no sorry that'll go in the positive y direction
Yeah, there you go.
because that's the upper bound of y, not x. And yeah, so it'll actually be this way. And yeah, so then the lower bound of y is x equals 0. So we're close off here. And then z goes from 0 to a paraboloid
16
that starts at the height of 16 and droops down. It's like if you held like up like a tissue and then it like droops down.
Yeah.
So, yeah, it's like paraboloid. It goes down like that. So yeah, that'll be up here at 16. It'll be going down like this.
It's a half a hill.
That chalk is on the last legs.
And then of course, because y never goes negative, we're bounded by a wall over here. So everyone sort of have an idea as to like what our region is looking like here. Can you sort of see from the sketch? So we have. I'm trying to think of what that would even call that.
Y never goes
It
negative.
would be like if you had like a Jello, and you were to like cut it in half, and
No,
look at like
quarters.
1/2 of it.
It'd be like a
It
quarter
might
of
look
a
something
jello.
like that.
It'd be a quarter of a jello, right?
It wouldn't be. It's a half of it.
It's like a half of a half.
Well, x goes from -4 to 4, so I think it's a half, not a quarter.
Yeah, it's half.
Yeah.
Wait, isn't
So,
y always positive?
It's a quarter of a football.
well, yeah, that's why it's a half.
Okay, and then x.
Because we're never over here, we're only over here. Yeah, so we have that.
Oh,
So
right, that
this
makes
speaks
sense.
to us
So
to
half
do
of the
cylindrical
football.
coordinates because we
No.
don't see the region's
Yeah, quarter of a
not a
football.
sphere clearly.
Half of
It's
it.
some like cut in half jello thing.
Yeah.
So we'll go to cylindrical coordinates. I spelled that incorrectly.
I think I did okay. Maybe look at this partial. What's this for drawing that?
Oh, I hope not.
You want
But
So for that we have x equals r cosine theta.
I thought you said lose partial points.
Y was cosine theta.
No, make get partial points for drawing.
And
Oh,
z is
probably,
equal
but you get the
to z.
answer right, you don't need to draw it.
That basically leave you
So-
lose partial points for not drawing.
Well, not necessarily. It just proves that you know.
We'll have to now write our new bounds. Oh, and by the way, the integrand.
Square root r squared.
Yeah, so that's the square root of r squared, which will just be r.
But then you have to
Then you
multiply
have to add
by
another
r.
Yeah, so then you have to
theta.
multiply by r, dr, d theta. And then r comes from taking the Jacobian.
And don't forget
And
z.
yes, there's the z.
Which actually might be easier to do dc.
Yeah, so we'll
dr
do-
theta.
Yeah, we'll do dz, dr, d theta. I've already included the extra r here. So z goes from 0 to 16
Yeah.
minus the sum of x and y squared, so that will be minus r squared. And r
Goes from 0 to
goes
4.
from
Pi squared
0
sine.
to, well, looking
0
here,
to
you can
4.
see it goes from 0 to 4.
Only square root uses pi.
Yeah, and then theta goes from
0 to pi.
0 to pi. Is that actually true though?
Yeah.
Just that, well, the thing is, for the radius, is you're like closer up here. That's not gonna go to 4, that's gonna go to number less than
Wouldn't it
4.
go to negative, from negative pi over 2 to pi over 2?
Yeah, I don't think that's 4. I think that shouldn't be 4. That should be.
Well, yeah,
Well, we're
theta
integrating
goes
over the
from negative
radius
pi over 2
earlier,
pi over
and
2.
that's the 10 minus r squared, so I think that's fine.
I think.
Yeah, I don't think that should go to 4.
I think.
You're right.
That should be fine.
Alright.
No, because the radius isn't always.
Yeah, the radius, well,
No,
yeah,
that's
you can clearly see here the radius is not 4.
Yeah.
So it's not actually.
Yeah, well,
Yeah.
you're integrating over a changing radius.
Yeah,
over
but
the
yeah, it
first
would be
one.
the same
Wait.
because it's.
No, we're just integrating over z.
Oh, so you have to integrate.
We
all
haven't
of it.
accounted for the radius yet. We haven't accounted for the
Okay.
radius or the angle at this point. At this point in time, we've not accounted for the radius or the angle.
We should probably integrate over
So,
the radius
to-
first.
So, or sorry, at this point, we've not accounted for the radius.
Could it be 0
Right.
from the
So-
square root of 16 minus, and then?
Yeah, so this would have to be the square root of 16 minus
Z.
Cosine,
Square root of 16 minus z.
R squared cosine squared theta?
We can have r because we have r here though. That's the.
Z equals 16 minus r squared. So just swap the r squared.
What if
R
you
squared
put
equals
in-
16 minus z.
Actually put in the radius first.
R equals square root 16 minus z. And then you could integrate that from 0 to 16 because that's the range of z.
Maybe it simply is just 4.
I think it's just 4.
It might actually just be 4.
I think it's
I
just
feel like that would be way too
I think you're
complicated.
taking that into
Yeah.
account by subtracting the r squared.
Yeah,
Yeah.
I'm thinking that. Yeah.
Should just be.
Anyway, so I'm gonna see if the question actually said to solve it or not.
I don't want to solve
Oh,
2
of course it
pi
says.
4 to the 5th over 15.
Love it. All right, so we're gonna have to. This is just gonna be a polynomial.
yeah.
16
Is it okay if I
squared
say
minus
that?
r to the 4.
Yes.
So everyone's okay if I
Well,
put
what
like
is
a
the answer
secondary
you
here
got?
and say it's simple?
What's the answer you got on your?
Except it actually is
He doesn't
simple,
have an answer.
as opposed to when he does it, it's not simple.
That's it.
Okay,
You didn't
anyway.
do this before you got here? Okay. Whatever.
Are there other questions before I raise this to go to the next one?
2 pi 4 to the 5th.
All right, so.
I don't trust myself.